Welcome back to our journey in creating a guitar pedal app using QML and Qt Quick. In this video, we're building upon the visual elements and inline components we created previously by exploring simple input, the heart of any application. Let's start by looking at the images we have. You may notice we do have duplicates ending in @2x. This is so we can support higher resolution and higher pixel density monitors. We will ignore those for now. However, you may notice that some of the images end with the word checked. This is what we will focus on. These images allow us to display a potential change in state to the user. For example, toggling a switch, pressing a button, and letting the user know this change has occurred visually. For our guitar pedal, we will turn on our LED when the pedal is pressed and simulate the movement of the mode switch by moving it from the down to the up position. As all these inputs share the same naming convention, ending with checked when toggled, we can set up an inline component to switch the image when our application detects input with the element. Let's start by creating a component that handles the switching of the image when the state changes from unchecked to checked. We'll name the component switchImage. This component is derived from image and has two properties, a string for the source image's name and a Boolean property. The source base name property is set as required, but what does this mean? Required properties are crucial in ensuring that every instance of our switch image has essential attributes defined. Think of them as mandatory fields in a form. Without them, the form, or in our case, the component, won't work correctly. In switch image, we are using this to define the base name for that instance of the switch image. Then we have the Boolean property, which, when true, adds checked to the file name and when false, doesn't add anything. You may also notice that the syntax for the source is slightly different from the previous steps. We use JavaScript template literals marked by the backticks. Template literals allow us to embed expressions within strings. The $ curly brace syntax is used to insert the value of an expression into the string. This means that we can pass the value of source base name and have the conditional operator that returns the additional string depending on the state of the component, checked or unchecked. We can test this first with the LED. We'll create an instance of switch image and position it as a child of the window component, about 1/3 from the left side and some spacing from the top edge. Remember, source base name is required, so we must give the instance the name of the image set we want to use. We will set the checked property to false for now. We will connect it to the pedal later. Let's build and run and see how our LED looks. It looks okay, but we should add some text below the LED and test what happens if we set the LED check to true. So, let's set the checked value to true. And then, using the device text component we made in the last video, we can add a label underneath the LED and anchor it in place with a small margin. Let's build and run again. Perfect, the LED is now lit, and we have a nice little label underneath. Now, onto our pedal and switch. We have our basis for switching images to display different states within our app to our users, but there is no way for them to interact with the app to modify the states. As we need similar functionality for the pedal and switch, we can use the switch image component as the basis for these interactable elements. So we can create another inline component that derives from switch image. Why separate the interactivity from the image? Well, our LED didn't need to be interacted with. We separate the visual aspect, the images, from the logic and functionality of the switch. This separation enhances maintainability and scalability. It allows us to reuse switch image in different contexts within our app with different sets of images without rewriting the logic each time. So we will create a new inline component named device switch, which derives from switch image. Let's add a component of type TapHandler as a child. TapHandler will allow us to detect the clicks of a mouse or taps on a touchscreen, meaning we could theoretically build our app for different devices that use different input methods. As we add interactivity to our guitar pedal app, it's crucial to understand how user actions trigger responses in the UI. This is where the signal and slot mechanism in QML come into play. In QML, the signal and slot mechanism is the way to communicate between objects. It's an elegant way of connecting a user action, signal, to a function, slot, that responds to that action. Think of it as a phone call. The signal is the ring and the slot is the person answering the phone. QML components have many predefined signals and slots that provide functionality for you to use. Here, TapHandler is an item that detects tapping or clicking actions. When a tap is detected on the component, it emits the tapped signal. This is our phone ringing. We can then perform an action by defining functionality with onTapped, the slot that responds to our TapHandler's signal. In our case, it's a simple line of code that toggles the checked property of the parent, our switch. Now let's use device switch to add our pedal. We will give the pedal an ID so we can attach its checked property to the checked property of the LED. This is called property binding. You may not have realized, but we have been using property bindings in our application already, specifically when anchoring components relative to a parent or another component in the application. Property bindings allow you to specify relationships between different object properties. When the property changes, it will update the objects it has a relationship with. In our case, updating the LED. Wrapping up the pedal will position it using anchors. Finally, the mode switch. For ease, we can make a copy of the LED instance and rename it to device switch. We can position it along the top of the window similarly to the LED. Remember, once again, we need to specify the source base name. We will also add a label below the switch that has the text mode. The mode switch image is quite small, so we may want to add some additional tappable area around the image. We will add a property to the tap handler using an alias that we can use to increase the margin area of the tap handler if needed. It's time for our final test. Everything seems to be working. In this video, we have dived into the interactive realms of QML and Qt Quick. Our guitar pedal app now not only looks good but feels alive with user interactivity. Using the signal and slot mechanism, we've connected the visual elements to the underlying logic, bridging the gap between user actions and app responses. We have built upon our knowledge of components by adding interactivity and added states that react to user input. Remember, the key here is experimentation and learning. Feel free to tweak the components, play around with the positions, and see how it changes the user experience. Each step is an opportunity to learn more about QML and Qt Quick. We are continuing to build a set of items you can use to make the app uniquely yours.